Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at the third sequence evaluation exam that was given to the further math students of St. Benedict Catholic Bilingual College. So this examination was written, marked and scripts distributed before these students went on holidays. I was the one who said the examination, so without wasting much of your time, let's get started. All right, before we begin, I want to give some special appreciation to all of you guys who have been following this channel from day one, since you maybe entered lower seat or upper seat, and all of you guys as well who have been there since last year, following the content, liking, sharing and subscribing to the channel. Special appreciation to you all, because without your likes, without your subscription, without your comments, this channel will not be progressing. Nevertheless, I'm going to give you guys some of the analytics of the channel. Okay, so first of all, we have about 2,930 subscribers already in the channel, and the objective is that we should have at least 3,000 subscribers before the end of the year. We are left with about 2 weeks. Anyways, I believe that you guys are going to share the video. You guys are going to talk about the channel to your friends, because I'm very convinced, with respect to the comments, that this channel is really helping you guys. And with respect to the views, we have about 85,000 views. That is when all the views are already accumulated, so they're about 85,000 views. So without your sharing, without even teachers who are watching, special appreciation to you all. Anyways, in another side, I'm going to talk about our website, which has already been built. In our website, so visit, just go to Google, I will type www.estudyuniverse.com. Then in our website, you'll be able to get past GC questions to all the subjects, though you might not find some questions in some subjects now, but just be checking the website. Subsequently, you're going to see the questions. Also, you're going to get past mock examination questions as well as pre-mock examination questions. You are going to get like in this video we are solving the sequence examination. Okay, so you're going to get sequence examination questions to schools that have come across already, and you're going to get the detailed solutions to the GC questions, both paper 1, paper 2, paper 3, to the examination questions, to the mock questions, to the sequence evaluation questions, and so on and so forth. Anyways, before we go, make sure you like the video, share the video with your friends, comment if the video is good, and also subscribe if you are new to the channel. All right, so let's get started. Okay, so the main thing we are going to be doing today is simply correcting one of the questions that came in the examination. We cannot correct all the questions because the video is going to be too lengthy. Okay, so I'm going to distribute. There were 5 questions basically. So the exam structure, we had 5 questions. Question 1 was 15 points, question 2 12 points, question 3 10 points, question 4 13 points, and question 5 15 points. But like I said, in this video we are going to be concentrating on solving just problem number 1, so that the video is going to be shorter. All right, so the chapters that came, question 1, in fact the chapters that came in general, we had elementary number theory, we had group theory, we had partial fractions, we had polynomials, we had mathematical reasoning, and we had polar coordinates. So these were the topics that featured in the examination. So a combination of these topics gave rise to the 5 questions that the students were supposed to answer. So in total, the examination was on 65, and it was actually marked on 65, but unfortunately I think just 3 students passed out of 100 and something students. Okay, but nevertheless, after after we solve the first question, I want to get your comments in the comment section. What you think about the question? Is the question too high for advanced level? Is it moderate, or is it below standard? So make sure you comment in the comment section as well. If you have a difficulty in understanding maybe a certain explanation, also comment in the comment section so that we can explain better in our next video. All right, so let's dive straight away into question number 1. All right, so question number 1, like we said, 15 points, and it was on number theory. So the question reads, it's a little bit lengthy, but we are going to read it together. Follow up. Consider the integer n, which is a, b, c, d base 7, where a, b, c, and d are numbers between 0 and 9 inclusive. Given that b is equal to the GCD of 40,321 and 35,287, where GCD of x and y represents the greatest common divisor of the integers x and y, and d is equal to b plus c. Also, the integer c is a unit digit of R such that 26 factorial is congruent to R mod 29, where R is between 0 and 29. Question A, determine b and hence d in terms of c. Question B, determine R and deduce c, and with this value of c, find the integer d. Given also that a is equal to the minimum value of alpha, where 11 beta minus 343 alpha is equal to 82 for alpha and beta in the set of positive integers. C, solve the linear Diophantine equation 11 beta minus 343 alpha equal to 82 and hence determine A. And D, find n and express it in the form PQRS base 10, where PQ, R, and S are natural numbers. So basically that was the equation. So I want us to first of all let's just talk about the main objective of the question. So this question, I actually released this question I think on the 11th of November 2023, where we were celebrating. If you were not celebrating, I was celebrating. We're celebrating the National Day of Single Men, okay, or the National Day of, yeah, I think single men. So I'm going to give you guys a story maybe in the description of this video so that you know clearly how I conceive the question, and at the end of the video I'm going to tell you the number we are going to have at the end of the video will in fact we are going to see. Okay, let's not talk much, let's just solve the question. If you want more information about how I was able to conceive the question with respect to that day, you visit the description of this video, or you check. I'm going to upload other videos talking about that particular question. That's this particular question in another sense. Alright, so let's go directly to the brief analysis of the question and the solution. So we are going to begin with, we are going to solve the questions sub question wise. So we take question A, we analyze the question. I tell you what you have to know about the question to be able to solve the question. That's the prerequisite knowledge you have to be able to solve the question. Okay, so I'm not going to read the question again. We are just going to start straight away with solving A part. A part says that we should determine B and hence D in terms of C. If we go back to the question, we realize that our B is the GCD of two numbers, and clearly GCD of x and y, meaning two integers, where is already defined, is defined as what? The greatest common divisor of the two integers. And the best way to find the greatest common divisor of two integers is to use Euclidean algorithm. And Euclidean algorithm is simply a series of division algorithms. So we have to recall what the GCD of two numbers is. The greatest common divisor of the integers x and y is simply the last non-zero remainder after a series of division algorithm of x by y or of y by x, depending on which one is larger. So that's basically the definition of the greatest common divisor of two integers. So we are going to begin by determining the value of b. Then after determining this value of b, since we have d as b plus c, we just need to replace our our b with its value, and then we have c, we have d in terms of c. All right, so let us begin. Now, how do we find the greatest common divisor of two integers? Like I said, we need to use Euclidean algorithm, where we have to express one of the biggest integer in terms of the smaller, and then we continue this process by using the remainder and the by using the remainder and the divisor until we get a last non-zero remainder. That last non-zero remainder is what we call the GCD of the two numbers. So I begin with 40,321. I need to divide it by 35,287. 1 is called the quotient and 5,034 is the remainder. Okay, now I now take the quotient, I now take what I have here, that is the divisor in the previous step, and I operate it with the remainder. So 35,287, if I divide it by 5,034, the whole part is going to be 7 and the remainder is going to be 49. I'll now take my divisor of the previous step and the remainder, and I continue the process till I get a last non-zero remainder. Like I said, the last non-zero remainder after a series of division algorithm is called the greatest common divisor of the two integers. All the steps we are doing here, we are doing division algorithm. Okay, so when we do it many times until we get a last non-zero remainder, that last non-zero remainder, I'm emphasizing, is called the GCD. Because when I was marking the papers, I realized that some students were confusing between the last non-zero remainder and then the quotient of the last non-zero remainder. So some students were instead interchanging and calling that quotient the GCD, whereas by definition we need to take the last non-zero remainder. All right, so let's proceed. We now take 49 and we divide by 36. It's going to go 49 on 36, the whole part is 1 and then the remainder is 13. We now take 36 and 13. 36 divided by 13 is 2, remainder 10. We now take 13 and 10. 13 divided by 10 is 1, remainder 3, and then we now take 10 and 3. 10 divided by 3 is 3, remainder 1. Now if we take 3 and 1, you realize that 3 will divide 1, there will be no remainder. So the remainder in the last division algorithm is going to be 0. Okay, and since that remainder is 0, it therefore means that the GCD of these two numbers is equal to 1, because we don't need the remainder which is 0, we need the last non-zero remainder. The last remainder will be 0, but the last remainder which is not 0 is simply 1. So the GCD of these two numbers is equal to 1. Now let me bring you guys back to what we call numbers that are relatively prime or numbers that are co-prime. So these numbers are basically relatively prime, or we can say the numbers are co-prime because their GCD, the greatest common divisor of the two integers, is equal to 1. So you should bear that in mind. All right, now from there it means that our b is equal to 1 because our b was the greatest common divisor of the two given integers. Now let us see how we can find d in terms of c. Since our b is equal to 1 and then our d was given in the equation as b plus c, it therefore means that our d will be equal to 1 plus c. So when I was marking, doing this you had 3 marks and doing this you had 1 mark. So you guys who maybe just ended here had your 3 marks. Without doing this you end no mark. So this a part was on 4. Remember the question is on 15, so I'm giving you how I mark the paper. All right, so let's go straight away to the second question. All right, so the b part of the equation is asking us to determine arrows and deduce c, and with this value of c find the integer d. Let's get back to the original question. The original question is saying that also the integer c is a unit digit of arrow such that 26 factorial is congruent to arrow mod 29, where arrow is between 0 and 29. So we need to solve this linear congruence to get R. In fact, we are simply finding the remainder when 26 factorial is divided by 29. R is that remainder, okay, because a congruent equation 26 factorial congruent to R mod 29 can be interpreted as this. R here is called the remainder when 26 factorial is divided by 29. So if we are able to get R, and we have been told in the equation that the integer c is a unit digit of R. So if you get R, then automatically we deduce c. And then since we had our d to be b plus c, and we had our b to be 1, and finding c means that we can easily find z. So we need to determine the value of R, okay. But now it is a little bit complicated to determine the value of R. So follow keenly what I'm going to do. Now there's a theorem that we call the Wilson's theorem. The Wilson's theorem is actually one of the last theorems in number theory. It says that if p is a prime number, then p minus 1 all factorial plus 1 is congruent to 0 mod p. We are saying that the integer p, which is a prime number, will always divide the integer p minus 1 all factorial plus 1. Okay, that's, if you read this congruence with what I explained previously, you're going to say 0 is the remainder when p minus 1 all factorial plus 1 is divided by p. And when the remainder is 0, it therefore means that one of the integers divides the other, or the bigger integer is divisible by the smaller integer. So anywhere I see kind of this factorial, I just think of the Wilson's theorem. Okay, so we are going to apply the Wilson's theorem, and then we use our knowledge of finding the modular inverse of a number or of an integer, then we get the value of R. So from the Wilson's theorem, what can we deduce? First of all, 29 is a prime number. It therefore means that 29 minus 1 all factorial plus 1 will be congruent to 0 mod 29. I've just replaced my p with 29. Remember, a prime number is a number that has 4 divisors, plus or minus 1 and plus or minus itself. 29 has 4 divisors, plus or minus 1, plus or minus 29. Therefore, it is a prime number. So since it is a prime number, therefore it must respect the Wilson's theorem, which says that itself minus 1 factorial plus 1 will be congruent to 0 mod itself. So 29 minus 1 all factorial plus 1 will be congruent to 0 mod 29. If we simplify, we get that 28 factorial, we subtract 1 on both sides. We subtract 1 on the left hand side, we get 0, and 0 minus 1 is negative 1. This is a property which we call the subtractive or the additive property of of congruences. Okay, so we have 28 factorial congruent to negative 1 mod 29. But now we have 26 factorial. So what can we do to 28 factorial to get 26 factorial? We just simplify 28 factorial as 28 times 27 times 26 factorial. Is also going to be congruent to negative 1 mod 29. Now if you look at this, for me to eliminate 28 times 27, because I need 26 factorial, I simply need to multiply both sides of this congruent equation by the multiplicative inverse or the modular inverse of 28 times 27. So we represent that modular inverse by 28 times 27 bar. Okay, this is the representation of that inverse. When you multiply it on the left hand side, the left hand side just becomes 26 factorial. That was the essence of eliminating it. When you multiply it on the right hand side, that is it. So the next thing we have to do is we need to find the inverse of 28 times 27 in mod 29, and we just replace it here. So what is the inverse of 28 times 27 in mod 9? Before that, we know that 28, there's another property we call these properties I'm applying here. This property here is the property, those are properties of linear congruences. Okay, so every integer will be congruent to itself in any mode. All right, so 28 will be congruent to itself in any mode. So we choose mode 29 because that's what we are working with. So 28 will be congruent to 28 mode 29, and 28 mode 29 is the same as negative 1 mode 29. We just need to take the 28 and we subtract 29. It's not a problem. And to convert it back, we can take negative 1 and we add it back to 29 to get 28. So 28 is congruent to negative 1 mode 29. If we multiply both sides by 27, we get 28 times 27 congruent to negative 1 times 27 is negative 27 mod 29. But to remove the negative sign, I'll just take negative 27 plus 29 to now get 2. Alright, so it means that if I take 28 times 27 and I divide by 29, 2 is a remainder. You could use your calculator to punch it and be very sure that 2 is your remainder. So I was basically finding a remainder when 28 times 27 is divided by 29. So 28 times 27 is congruent to 2 mod 29. Now the objective actually is to get the multiplicative or the modular inverse of 28 times 27 in mode 29. But what's the definition of that inverse? The inverse of a number, for example, the inverse of, let me try to write it down. So the inverse of maybe x, right, in a certain mode is a number that when you multiply by x, okay, let me just say that the inverse is a. If you multiply a by x, the result is going to be congruent to 1 in that mode. Let's just say that we are dealing in mode n. So the inverse of any number, we always solve the equation, the number, which is x, times its inverse congruent to 1 mod n. So we need to look for a number that when we multiply that number by 28 times 27 and we divide by 29, the remainder is 1. That's what we are looking for, okay? And that number is clearly 15, because if I take, remember that we have already seen that 28 times 27 is congruent to 2 mod 29. So if I multiply both sides of this equation by 15, remember 2 times 15 is 30, and 30 divided by 29, the remainder is 1, and that is what we need. So the inverse of 28 times 27 in mode 29 is clearly 15. Alright, so if you multiply both sides by 15, 2 times 15 is 30, and 30 is congruent to 1 mod 29. Okay, it therefore means that our 28, the inverse of 28 times 27 in mod 29 is 15. Alright, so we just need to come back here and replace 28 times 27 inverse with 15. Like I said, the multiplicative inverse of 28 times 27 in mod 29 is 15, because if you multiply 28 times 27 then times 15 and you divide by 29, the remainder is going to be 1, and the number here is 15. That is what we are looking for. Alright, so let us continue from here. We need to recall that the inverse of 28 times 27 in mode 29 is 15, and our d is equal to 1 plus c. So I just need to replace 28 times 27 inverse with 15. If you multiply by 1, we get negative 15. But I don't need a negative remainder, so I need to add negative 15 to 29. If I add negative 15 to 29, I get 14. I could also add 14 to 29, but I'm not going to add. Why? Because I need to get arrow between 0 and 29. If I'm adding 14 to 29, it's going to be more than 29. Okay, so it therefore means that if I compare 26 factorial congruent to arrow mod 29 alongside with 26 factorial congruent to 14 mod 29, what do we get? We get our arrow to be equal to 14, but since our c is a unit digit of arrow, unit digit, you know, 100 tens and unit or tens and unit, the unit digit of 14 is simply 4, so it means that our c is 4. And since our d is equal to 1 plus c, it means our d is equal to 1 plus 4, which is 5. So in conclusion, we can conclude that our b is 1, our c is 4, and then our d is equal to 5. All right, we are wrapping up. So let's check the C part of the equation. We need to solve the linear Diophantine equation. 11 beta minus 343 alpha equal to 82. And then after solving this, we determine A. Now let's get back to the equation. The equation that will help us to solve this is given also that our A is equal to the minimum of alpha. Alpha means the minimum of alpha, where alpha solves the linear Diophantine equation and alpha is positive. Okay, so we need to take into consideration all these conditions that are attached to alpha. Alpha will solve this linear Diophantine equation and it is supposed to be a positive number, and then our A is the minimum value of alpha. Normally, every linear Diophantine equation that has solutions always has infinite number of solutions. But now, if we base ourselves on A being equal to the minimum value of alpha, we need to take the minimum value of all the values of alpha. In fact, we need to take the minimum value of all the positive values of alpha, because alpha will be both positive and negative. But on the constraint that alpha is positive and our A is the minimum value of alpha, we'll be able to get the value of A. So let's start by solving this linear Diophantine equation. We are just going to solve for alpha. We don't actually need beta, since we are more concerned with getting the value of A. So to solve a linear Diophantine equation, what do? To solve a linear Diophantine equation, we need to find the GCD of 11 and 343. Then we do backward substitution to express the GCD in terms of the two integers. Then we deduce our initial solutions and then the general solution. So I begin with a bigger number. 343 is equal to, I divide by 11, it gives me, 11 goes there 31 times and the remainder is 2. And I'll take 11 and 2, since we are taking the divisor and the remainder in the previous step. So 11 divided by 2 is 5, remainder 1. You realize that if you take 2 and 1, 2 clearly will divide, 2 divided by 1 leaves no remainder. So the GCD is equal to 1, since it is the last non-zero remainder. Now we need to do backward substitution. To do backward substitution, I begin with the remainder, okay, because this backward substitution wants us to express the GCD of the two numbers in terms of the two numbers. So I begin with the second equation. I get 1. My 1 is equal to 11 minus 2 times 5. Now I go to the next equation and I look for 2. Okay, so 2 is simply 343 minus 11 times 31. So I keep the 5 which is attached to 2 and I replace 2 with its identity, 343 minus 11 times 31. Now I can distribute the 5 inside and I'm going to have 343 times 5. I make sure that 343 and 11 are not tampered. Okay, so when I'm multiplying negative 5 with negative 11 into 31, I'll just multiply the negative 5 and the negative sign and with the 31, and I'll leave the 11 there, because I need 343 and 11 to be in my final answer. So I now bring like terms together. 11 plus 11 times 155. You can factorize 11. Yes, 11 times 1. You just add the 1 to 155. You get 156 minus 343 times 5. Now, since here we have 82, okay, we need to multiply all through by 82, making sure that 11 and 343 are not tampered. So if you multiply all through by 82, I just need to multiply 156 with 82 and 5 with 82. Since we are more concerned with alpha, we can deduce the initial solution that our alpha 0 is equal to 410, because it is supposed to be the coefficient of 343 in the final backward substitution. That's after expressing the GCD in terms of the two numbers and multiplying all through by 82. So our 82 is simply equal to this. So our initial solution for alpha is 410. Okay, it exactly resembles this form, 11 beta. So if we're finding beta, we are going to say beta 0 is 12,792. Now, how do we deduce the general solution for alpha? So our alpha is equal to alpha 0 minus I believe you know the general solution of a linear Diophantine equation, px plus qy equal to r. So here's my general solution for alpha. Okay, now we know that alpha and beta are positive. So alpha being positive, it means that 410 minus 11t is positive. If we solve for t, our t will be less than 410 on 11, and 410 over 11 is 37.2. If you are less than 37.2, it means you are less than or equal to 37, since you are a whole number. Now we can list some values of alpha. We begin with t equal to 37. Our alpha will give us 410 minus 11 times 37 is going to give us 3. If we replace t to be 36, because you have to be less than or equal to 37, and you are a whole number, so you are 37, 36, 35, and so on. If we use 36, we are going to have alpha to be 410 minus 11 times 36, which will give us 14, and so on and so forth. But since our a was a minimum value of alpha, it therefore means that our a is equal to 3, because you're going to have the values of alpha are going to be increasing from 3 to 14 to the next values. So since our integer a is the smallest, minimum means smallest, okay, so the smallest value in this set is simply 3. So we can conclude that our a is equal to 3. Alright, so having our a, b, c, and d to be 3, 1, 4, and 5, we can now solve the last part peacefully. We need to find our n. Our n was given as a, b, c, d in base 7. We need to find it in base 10. Okay, we need to find our n and then we express it in base 10. So basically, since our n is a, b, c, d base 7 and we have a, b, c, d already, our n will be equal to 3147 base 7. Okay, that's how we read numbers in a base, because we cannot say 3000, that is already more than 7. So we say 3145 in base 7. Since our a is 3, our b is 1, our c is 4, and our d is 5. Now, how do we convert this to base 10? We just need to do the normal conversion. We take the first integer, the first digit from the right, from the left, which is 3. We multiply it by the base to the power the remaining number of numbers. If I cover 3, I'm going to be left with 3 numbers, 1, 4, and 5. So I take 3 times 7 to the power 3, because there are just 3 numbers left. Plus, if I take 1 and I cover, I'm going to be left with 4 and 5. Those are 2 numbers, so I get 1 times 7 to the power 2. If I cover 4, I'm going to be left with only 1 number, which is 5. So it is 4 times 5. 4 times 7 to the power 1. And if I cover 7, if I cover 5, I'm going to be left with no number. That's why I have 5 times 7 to the power 0. So if we simplify, we get 343 times 3, 1 times 49, 4 times 7, and 5 times 1. In conclusion, our n is equal to 1111 in base 10. So this is the end of the exercise. Thank you guys for watching. If you have a difficulty, like I said, the comment section is open for you to pour out your worries. If you have a difficulty with an explanation, or you want me to do more videos on number theory, tell me in the comment section, so I'm going to prepare videos in number theory and upload. If you have a particular difficulty with number theory, voice out your difficulties in the comment section. Before going, don't forget to like the video, very important. Share the video with your friends of other schools. Subscribe to the channel if you're new to the channel. Okay, comment, because your comments will tell me if I should do more videos on number theory, or I should not upload videos again on number theory. It depends on you, because I upload videos based on what you want to see, because you're the one watching. Okay, so make sure you comment. If the video is good as well, it's going to encourage me, it's going to motivate me, because your comments, nice comments as well, go a long way to motivate me. When I'm doing other videos, I can add, or I can do many other videos. Okay, so do well to comment if it is good. Do well to comment even if it is not good. Make sure you also comment, so that in the next video I'm going to improve on my explanation, so you get it very well. So guys, like I said, stay tuned for exercise number 2, which I'm going to be uploading after maybe like 3 days. Okay, so don't forget to share the video with your friends, very important. Okay, very important. Thank you guys for watching. I'm going to, like I said at the beginning, I'm going to tell you how this question was conceived and what 11111 represents. So just I said this question was released on the 11th of November. 11th of November is 11 of 11. The day was the 11th and the month is 11. So something happened on that day and it brought forth I can say it brought forth the production or the manufacturing of this question. So thank you guys for watching. Stay tuned and see you in the next video.